Hi, I am Rahul Diwan.
And this is Shweta Nathani, and in this screen capture, we are going to show how to evaluate an arithmetic expression using LEX and YACC.
So let's start. Firstly, we'll look at lex. In particular, we are going to give you a brief introduction to lexical analysis. We will talk about what lex exactly is and how it works. So we start out with a source file and feed it to the scanner, which is known as lexical analyzer, which produces a stream of tokens and which we feed it to the parser, which does syntactical analysis and produces a parse tree. This parse tree can be fed into another parser that does semantic analysis and code generation, which produces an intermediate form which goes into the target code generator and ultimately produces a new file of the target language. Lex file takes the regular expression and their corresponding actions as their input and give a table driven output which it stores in a self-generated file named at lex.yy.c. Now we come to the format of a Lex program. Basically, a Lex program is divided into three parts separated by %%. First part contains lines that control dimensions of tables that are generated by lex. It can also it can also contain definitions, global C codes that are going to be utilized by the actions. In the second part, regular expressions are listed along with the actions. Action can be a single C statement or a block. Third part contains C codes that is simply used as it is. Also, if you are using a multiple line input, then you have to use function called YYWrap, which returns 1 when for successful wrapping. So to conclude Lex, we have some basic rules to be followed. They are %% is used as a terminator to separate the three sections. First and third parts are optional. Extension of a lex file is .l. Steps to run a lex file. For a file named file1.l, type lexfile1.l. A file lex.yy.c will be generated. Then, to compile the C file, type gcc lex.yy.c and an executable file a.out will be generated.
And now we will look at YACC. First of all, we will talk about what exactly YACC is, how it works, and then we will look at the program code and see how it works. Here we will look at the second and third block of the language processing, that is, the parser and the semantic analyzer. YACC and LEX are used together. YACC stands for Yet Another Compiler. It does parsing and semantic processing on the stream of tokens produced by LEX and also manages the parse tree. Input of a YACC file is a context-free grammar. The analyzer produces a parse tree and then meaning of that expression is evaluated. Format of a YACC program. Basically, a YACC program is divided into three parts separated by percentage. First part contains C declarations, YACC definitions like percentage start, percentage token and many more. Second part, also known as production part, represents context-free grammar. The multiple options are separated by the OR character. Actions are entered in braces. The third part contains a valid C code that supports language processing, the implementation of a symbol table called SymTab, and the functions that might be called by actions associated with the production in second part.
Time to get practical. See, there are two files in my directory, lex underscore project, project.l, that's the lex file, and project.y, that's the YACC file. Compiling the lex file, type lex space file name, that is project.l, and press enter. It's successful. Now compile the YACC file with the "-d" attribute to create y.tab.h. As a result, type "YACC space "-d" space project name project.y", press enter. See the directory. The result of lex was the file lex.yy.c, and the result of YACC are the files y.tab.c and y.tab.h. Now we have two C files, that is, two files of the C programming language. We'll compile them using the GCC compiler. To do so, type gcc space first file name, that's lex.yy.c, then second file name, that's y.tab.c. Compilation is successful without any errors. Again, we see an executable file a.out that's created. Run this file. Now I'll show you what my program does. Printing the value of variable a, it's 0. Now I assign the variable a with the value 3, variable b with the value 5. C shows addition of a and b, printing c. D shows subtraction of a and b, printing d. E shows multiplication of a and b, printing E. F shows division of a and b, printing F. All the answers are correct. So here was the presentation of my project. Now I should exit this program by typing exit.